Hello to whoever is watching. In this video, I am going to talk about advanced counting techniques. A recurrence relation is an equation that recursively defines the sequence where the next term is a function of the previous term. One of an example is Fibonacci sequence. Look at this sequence. We can see that the sum of previous two terms forms the next term. So now, we will more focus on counting bit strings. We have to find a recurrence relation and give the initial conditions for the number of bit strings with length n. For the first question, we have to find the number of bit strings of length n without two consecutive zeros. And we have to find the initial conditions before we answer the question. The n here means the number of bit strings of length n without two consecutive zeros. For A1, it is 2, because it is either 0 or 1. Both of them do not contain two consecutive zeros. And for A2, it is equal to 3, 0, 1, 1, 0, and 1, 1. Now, let's watch a problem-solving video by me to help you gain more understanding. Now, let's say the n is 3. N is the length of the bit string, and we split it into two conditions. First, it ends with a 1, and the second condition is it ends with a 0. So what does it mean if ending with a 1? So we can see that the last bit here, it is 1. And since we already know the last bit is 1, so there are only n minus 1 remaining bit in front of it. So that's why there are only two spaces here left. Two empty spaces here, 1, 2, and 3. We already know is 1. And for second condition, which is the n with 0, and the last bit is 0, and since the question does not include two consecutive 0, so we know that the bit in front of it must not be a 0, which means it is a 1. So that's why we confirm that it's 1, 0 here. Okay, so and now we back to the first condition, and with a 1. So basically we already know the last bit is 1, so we just need to identify the first two bits here. We have to know how many possible outcomes here that are without two consecutive 0. And this is actually A2 here, because A2 means that the number of bit string with the length is 2 that are without two consecutive zeros, and we already have A2 as our initial condition, which is 3. Okay, so and we come to the second condition, and with 0, and we only have one empty space here, which means it is actually A1. Yeah, because the length of the bit string is 1 only, and we know that A1 as our condition code is 2, either 0 or 1. So what we can say from this, or what rules can we come up with? It is A3 equals to A2, which is the first condition ending with 1, plus A1, the second condition ending with 0. And overall, this is the recurrence relation. Using the recurrence relation, we can get A3, A4, and A5 based on the previous terms. And notice that the sequence resembles Fibonacci sequence, because 2 plus 3 is 5, and 3 plus 5 is 8, and so on. Now we move to the second question, and in this question, we have to find the number of bit string with length n that has 3 consecutive zeros. The initial conditions for A1 and A2 are both 0, because we cannot have 3 digits if the length is 1 or 2. And for A3, there's only one option, which is 0, 0, 0. Let's assume the n is 4, meaning that the length of the bit string is 4. And also we need to split it into two different conditions. First is n with a 1, and the second is n with a 0. Now we first focus on the n with a 1 first. And now we can see that the last bit is 1, and so there are remaining n minus 1 here in front of it. So that's why there is 1, 2, 3 empty spaces in front of this last bit. And so now we have to find what is the possible outcome that for this first 3 bits it will give us the 3 consecutive zeros as the question wants us to find. So this is actually A3. Yeah, because the length of the bit string is 3, and we need to get like how many possible outcomes for 0, 0, 0, and of course there is only one outcome only, so A3 is 1. Okay, then we settle with ending with a 1. Now we move on to ending with 0. Okay, so if we end the last bit with a 0, it can give us many different possibilities. First, it is 0, and the second last is 1. Okay, and sure, we have already confirmed the last 2 bits, so we only have 2 empty bits remaining. And we need to get 3 consecutive zeros in 2 bits is impossible, right? So this means A2 is 0. Yeah, same as our initial conditions. A2 is 0. Another condition is the last bit is 0 and the second last bit is also a 0. And this will also give us another different possibilities, and which is 0, 0, 0 or 1, 0, 0. Okay, now let's look into this condition first. Because the question wants us to get 3 consecutive zeros, and we already made it. We have already fulfilled the questions. So whatever the bit string in front of it, I can accept it. We can take it no matter what it is, because we already fulfilled the questions. So, and how many bits remaining here? 3 bits are already taken by these 3 zeros, so the remaining bits are n minus 3. So we can take it all the possible outcomes. This is actually 2 to the power of n minus 3. And for this question, of course, n is 4, right? So for this question is actually equals to 2 to the power of 1, which is 2, because only 1 bit is remain here. Then we look to this condition. It's ending with 1, 0, 0. Now we still have to get 3 consecutive zeros, and this is where we have to work. We have to find how many possible outcomes for 3 consecutive zeros for the bits here. For the bits remaining is n minus 3. So this is actually a n minus 3. For this question, n is 4, so it's actually equals to a1, which is also 0, as stated in our initial conditions. This question, to calculate a4, we need to include a3, which is 1, a2, which is 0, 2 to the power of n minus 3, which is 2, and lastly a n minus 3, which is 0 here. And overall, this is the recurrence relation for this question.
Again, using the recurrence relation, we can get A4, A5 and A6 based on the previous term. But notice that this sequence is not a Fibonacci sequence. That's all from me. Thank you very much for your watching.